You're listening to DTF for April 6th, 2026. I'm your mass decompiled host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where mass extinction events and hobby projects share a comment section. Today's a day for things that fit in your pocket and punch above their weight class. Let's get into it. In year 1994, the Clipper chip proposed that every encryption device sold in America would contain a government-held backdoor key. The technical community revolted. The proposal died, but the impulse behind it: build surveillance into the infrastructure and call it safety. That impulse never went away. It just learned to wear better masks. What we're looking at today is an independent decompilation of the Persona SDK, the age verification system now embedded in apps like Roblox, and the findings are damning in the most technical, line-by-line, reproducible sense of the word. Let's start with the fundamental architectural problem. Age verification requires proof of identity. Proof of identity requires data collection. Data collection at scale is surveillance. There is no technical design that squares this circle while remaining centralized and closed source. This is not a policy opinion. It is a constraint, like thermodynamics. Persona's SDK, version 2.32.3, built March 11th of this year, contains a hard-coded AES 256-GCM encryption key. Hard-coded. In every copy of the APK, the key is right there in tracking event of -AR-DAVA. Line 22. Every telemetry event your device sends gets encrypted with this key before transmission. But since the key ships in every publicly downloadable app, anyone can decrypt those payloads. This is not encryption. This is obfuscation designed to look like encryption. The researchers built a standalone Python decryptor and verified it with round-trip testing. It gets worse. The SDK implements zero-certificate pinning, the auxiliary client builder chain, and then workings up to contains no call to certificate pinner at any point. A standard man-in-the-middle proxy with a user-installed CA certificate can capture and decrypt all Persona telemetry from any app embedding this SDK. On a coffee shop Wi-Fi network, on a school network, anywhere. And while this unprotected fake encrypted data flows outward, 7 simultaneous analytic services are watching every user who goes through verification. 7. For an age check. This is the architecture of mass surveillance wearing the language of child safety, and it is closed, proprietary, unauditable. Except by researchers willing to decompile APKs and publish what they find, the Clipper chip failed because cryptographers could examine it and explain what it actually did. The same thing is happening here, 32 years later, because the tools exist and people are using them. J.D. Dix, publicly available APKs, standard reverse engineering methodology. The gatekeepers didn't plan on anyone checking their work. Age verification mandates are proliferating across legislatures worldwide. Before another law passes requiring this technology, every policymaker should read this decompilation report. Because the question was never whether we can verify age online. The question is, what infrastructure gets built in the process? And who it actually serves? The code answers that question clearly, and the code is now public for anyone to verify. So what happens when someone decides the best way to understand AI isn't to fear it, but to build one small enough to hold in your hands? 4096. That's the entire vocabulary. GupLM knows 4096 tokens, and with them it constructs sentences like, "You're my favorite big shape," and "the meaning of life is food." For reference, GPT-4 uses a vocabulary around 100,000 tokens. This model gets by on 4% of that. And somehow, within those constraints, it develops something that feels suspiciously like personality. Let me play devil's advocate for a moment. You could argue this is a toy. 8.7 million parameters, 6 transformer layers, trained on synthetic data in 5 minutes on a free Colab GPU. It can't write an essay. It can't summarize a research paper. It doesn't know what a phone is. By any benchmark that matters in the AI industry, GuppiLM is useless. And that's precisely what makes it beautiful. Armambidi built a vanilla transformer. No grouped query attention. No rotary position embeddings. No sweet value activation. Every optimization trick that makes modern LLMs efficient and opaque has been deliberately left out. What remains is the skeleton. The pure architecture that everything else is built on. You can read the model.py file and understand every matrix multiplication. You can trace a token from input embedding through 6 attention layers to output logit and never lose the thread. Try doing that with Llama 3. The dataset design is where the craft really shows. 60 topics, 60,000 conversations, all synthetic, all generated through template composition. Greetings, feelings, temperature, food, bubbles, cats, rain, the meaning of life. Each category teaches the model a slice of what it means to be a small fish in a glass box. The constraints aren't limitations. They're the curriculum. By restricting the world model to water and food and light, every architectural decision becomes visible in the output. When Guppy says, "I hide behind the plant when the furry one comes," you can trace exactly why those tokens were selected, in what order, with what probability. The weight tying between the embedding layer and the language model head is a nice touch. It means the same matrix that converts tokens into vectors also converts vectors back into tokens. Elegant symmetry that cuts parameter count and makes the whole system easier to reason about. One comment on Hacker News nailed it. This is arguably the most honest language model ever built. It knows it lives in a tank. It knows it wants food. It doesn't hallucinate capabilities it doesn't have. There's a lesson in there about what happens when you build a model whose training data perfectly matches its intended domain. No alignment tax, no safety theater. Just a fish that knows exactly what it is. The entire thing runs in a browser. Train it in 5 minutes. Chat with it immediately. Read every line of code that produced it. This is what demystification actually looks like. Not a blog post explaining attention mechanisms with diagrams, but a living model small enough to hold in your head. The tools exist. A Colab notebook and curiosity. That's the whole stack. 3 stories in and we're speed running the entire compute ladder. You'll pause from browser tab to iPhone. Let's keep climbing. What does it mean when the company that built the cloud wants you to leave it? Google. The entity whose entire revenue model depends on your data traveling through their servers. Just shipped an app that runs a frontier-class language model entirely on your iPhone. No network connection, no telemetry, no round trip to a data center in Iowa. Gemma 4, sitting in your pocket, reasoning about your photos, transcribing your voice, executing agent tasks, and doing all of it without Google ever seeing a single token. Let's pull this thread, because the question nobody seems to be asking is, why would Google do this? They're not a charity. They didn't wake up one morning seized by a passion for digital sovereignty. The answer, I think, is more interesting than altruism. Google looked at the trajectory of on-device compute and realized that if local AI is inevitable, and it is, then the winning move is to be the model people reach for when they run it locally. You can't monetize inference you never touch, but you can become the default. and defaults are worth more than API calls. The app itself is genuinely impressive. Gemma 4 with thinking mode. You can watch the reasoning steps unfold on your phone, agent skills that call Wikipedia, render maps, generate visual summaries, all without a network connection. There's a tool calling model called function Gemma that's 270 million parameters and handles device automation. One commenter said they built a real-time audio and video AI pipeline on an M3 using Gemma, which tracked. This model punches way above its weight class. And here's what matters architecturally. The whole thing is open source. The app, the model weights, the agent skill framework. It's all on GitHub. Someone in the comments made the point that the only sustainable future for AI is either local and nearly free, or cloud and dramatically more expensive than today. I think that's exactly right, and I think Google knows it too. A 4 billion parameter model doing agent work on a phone that fits in your jeans. Open weights, open code. Community contributed skills loaded from URLs. This is what the distribution of power actually looks like in practice. Not a manifesto, not a policy paper, but a model running on hardware you already own, doing useful work, answering to nobody. The tools exist. They're in the App Store. That sentence alone would have been science fiction 3 years ago. Moving on. $15 billion. That's the profit France's central bank booked. Not by trading gold, not by speculating, but by doing something beautifully simple. They sold old gold bars sitting in American vaults at today's prices, then bought equivalent new bullion in Europe at the same market rate. The tonnage didn't change. France still holds roughly 2,437 tons. But the accounting gain is real because those original bars were carried on the books at historical cost. Prices from decades ago, when gold was a fraction of what it is today. Let's break this down to first principles, because the mechanics here are genuinely elegant. Central banks don't mark their gold reserves to market the way a hedge fund would. They carry them at acquisition costs. France had bars in the New York Fed's vault. Bars that were purchased or deposited when gold was, say, $300, $400 an ounce. Gold today trades above $2,000. When you sell at current prices and simultaneously buy at current prices elsewhere, your tonnage is unchanged. Your physical exposure is unchanged, but you realize the paper gain that was locked inside that historical cost basis. It's an accounting event, not a market bet. The engineering of the transaction matters too. France didn't actually ship gold across the Atlantic. Refining, transporting, insuring 2,400 tons of gold. That's a logistical nightmare and an enormous expense. Instead, they sold the American vaulted bars and purchased replacement bullion already in Europe. Clean, efficient. The kind of operation that looks trivial on paper, but represents serious institutional competence. Now, the geopolitical layer. Someone in the comments invoked Nixon. 1971, when France literally sent a warship to collect gold, and Nixon responded by closing the gold window entirely, ending dollar-to-gold convertibility. That history rhymes. Multiple nations have been repatriating gold reserves over the past decade. Germany did it. The Netherlands did it. The pattern is unmistakable. A slow, quiet redistribution of sovereign reserves away from centralized American vaults and back to national territory. This is sovereignty expressed in metal, and the $15 billion gain is almost a bonus. A side effect of competent accounting layered on top of a strategic decision that was coming regardless. France wanted its gold home. The fact that the move also crystallized half a century of unrealized gains is just good crap. Now, sovereignty over your own stack matters too, and Microsoft's been fumbling that ball since the Petzold era. Let me make the case for Microsoft. Seriously, you have a platform serving 1 billion devices across tablets, desktops, laptops, mixed reality headsets, and embedded systems. The hardware landscape shifts every 3 years. Of course you need multiple UI frameworks. No single abstraction could possibly span that surface area. WPF was right for 2006. UWP was right for the App Store era. WinUI 3 is right for modern compositing. Each framework was a rational response to a real constraint. This is engineering pragmatism, not dysfunction. That's the argument, and it is completely, devastatingly wrong. Jeffrey Snover, the man who built PowerShell, just published a 30-year autopsy of Microsoft's GUI strategy, and the diagnosis is architectural, not technical, architectural. Every framework Microsoft shipped after Win32 was a technically defensible answer to the wrong question. The question was never, what rendering pipeline should we use? The question was, how should a developer build a Windows app? And Microsoft hasn't been able to answer that in a single sentence since Charles Petzold published an 852-page book in 1988. Here's the comedy. Each framework died the same way. MFC wrapped Win32 in C++ and became a tuxedo made of other tuxedos. WPF was GPU accelerated, vector-based, genuinely visionary. And the Windows team refused to use it in their own shell. Silverlight was WPF for the web until it wasn't. UWP was the universal platform that universal developers universally avoided. WinUI 3 is the current answer, which means it's the current answer until the next keynote. Snover calls it the conference keynote problem. Leadership optimized for impressive demos, not developer success. Every PDC brought a new framework because a new framework makes a better slide than we improved the one you already know. Now apply the architecture test. Every one of these frameworks was proprietary. Everyone locked you deeper into a platform whose own team couldn't agree on its direction. Meanwhile, the actual answer to how do I build a desktop app became Electron. A web browser wrapped in Node, built on open technologies that nobody controls. The web won the GUI wars by accident. HTML, CSS, JavaScript. Ugly, incoherent, designed by committee. But open! Any developer can ship to any platform. The specification belongs to everyone. When Microsoft's own engineers couldn't pick a Microsoft framework, they picked the open one. One commenter nails it. It's 2026. We run photorealistic games at high frame rates, and resizing a settings window on the same machine stutters. That's not a performance problem. That's what happens when your platform has 6 rendering pipelines and nobody knows which one the window in front of them is using. The tools to build beautiful, fast, native interfaces exist. They've existed for years. The missing ingredient was never technology. It was the willingness to pick one answer and commit to it, which requires the one thing a proprietary platform cannot do: give up control. So what happens when that same open hardware energy points at the sky? Story 6, Moon Bounce. I once spent 3 weeks debugging a beamforming algorithm for a 4-element array. 4 antennas. The phase calibration alone nearly broke me. So when I tell you that someone has built an open-source 240-element phased array that bounces signals off the moon, I need you to understand the magnitude of what that sentence contains. Earth-Moon Earth communication. You transmit a signal. It travels 239,000 miles to the lunar surface, reflects, and travels 239,000 miles back. Round trip, about 2.5 seconds at the speed of light. The path loss is enormous. For decades, this required antenna arrays the size of buildings, kilowatts of transmit power, and the kind of budget that assumes you have a university or a government behind you. Moon RF does it with a board that fits on a tripod. Target price, $399. The engineering is genuinely remarkable. They reverse-engineered the Raspberry Pi 5's MIP interface to push 5.6 gigabits per second from custom Sigma Delta analog to digital converters through a Lattice ECP5 FPGA into the Pi. That's not a hobby project, pretending to be serious. That's serious engineering, choosing to be a hobby project. The entire signal chain is software-defined. The beam steering, the tracking, the signal processing. All in code, all open. Run this forward. A $400 box that can coherently aim 240 antennas at any point in the sky using software. Today, it bounces signals off the moon. Tomorrow someone adapts it for radio astronomy. Someone else uses the phased array techniques for mesh networking. Someone builds a synthetic aperture radar for crop monitoring. The architecture is the gift, not the application. One commenter asks how it compares to a single antenna on a Starlink satellite. The answer misses the point entirely. Starlink is a service you subscribe to. This is a capability you own. You can read every line of the firmware. You can modify the beamforming weights. You can point it wherever you want, whenever you want, and nobody can push an update that tells you otherwise. The moon is 250,000 miles away. The tools to reach it cost less than a good bicycle, and every schematic is published. Moving on. A queen ant, freshly mated, wings still attached, pulled from a nuptial flight in Turkey or Spain or Japan, packaged in a test tube with a damp cotton ball, shipped across borders in a padded envelope. Listed price, $220. This is wildlife trafficking, and the fact that it sounds absurd is exactly what makes it work. The BBC is reporting on a growing global black market in live ants. Specifically queen ants, because a queen is the only way to start a colony. The hobby of ant keeping has exploded. Transparent formicaria. Those flat acrylic enclosures where you can watch tunnels form in real time, have turned myrmecology into a consumer product, and where there's demand, supply finds a way. Follow the logic to its end. Ant keeping is legal in many countries. Selling native species is often fine, but the market doesn't want native species. It wants exotic. Leaf cutters from South America, weaver ants from Southeast Asia, species that cannot legally cross borders because, and this is the part that actually matters, invasive ant species are among the most destructive organisms on Earth. Fire ants cause billions in agricultural damage annually. Argentine ants have formed supercolonies spanning entire continents. A single escaped queen with a sperm reservoir carrying enough genetic material to produce millions of workers isn't a pet that got loose. It's an ecological event. The trafficking networks mirror exactly what you'd expect. Social media storefronts, encrypted messaging for transactions, mislabeled packages declaring harmless insects or educational materials, customs agents who don't know a camponotus from a chromatogaster. The interdiction rate is almost certainly negligible because nobody is looking. What makes this genuinely serious is the asymmetry. The upside is a hobby. Someone gets to watch tiny insects dig tunnels on their desk. The downside is the potential introduction of an invasive species into an ecosystem that has no defense against it. That's not a proportional risk. Every biological system is an open system in the truest sense. Interconnected, adaptive, and irreversible once disrupted, you cannot patch an ecosystem. There is no rollback. The queen either founds a colony or she doesn't, and the person who ordered her online will never know which one happened after she escapes a cracked test tube in a climate she was never supposed to reach. Moving on. In 1964, Dartmouth powered up its time-sharing system and gave students access to BASIC. The radical idea wasn't the language, it was the feedback loop. You typed a line, you hit run, you saw what happened. No punch cards, no waiting for batch processing, no priesthood standing between you and the machine. John Kemeny and Thomas Kurtz understood something that most language designers miss. The distance between intention and result is the only metric that matters for learning. LÖVE is a direct descendant of that philosophy, and it's gorgeous in its simplicity. Think of it like a well-seasoned carbon steel pan. A professional kitchen is full of specialized equipment. Immersion circulators, combines, blast chillers, but the pan is where you learn what heat actually does to food. You develop intuition through direct contact. LÖVE is that pan for game development. You write Lua. You call love.draw. Pixels appear. The distance between your idea and a moving thing on screen is measured in minutes, not months. Balatro, one of the biggest indie hits in recent memory, was built in LÖVE. That's not a toy framework producing a novelty game. That's a tool with enough depth to ship something millions of people played. The API surface is deliberately small. Drawing, audio, physics, input. Everything a two-dimensional game needs and nothing it doesn't. What I genuinely admire is the architectural restraint. Cross-platform support spanning Windows, macOS, Linux, Android, and iOS from a C++ core with Lua scripting on top. The test suite covers every API the way developers actually use them. Drag a zip file onto the executable and your game runs. That deployment model is almost disrespectfully simple. The project is fully open source under a permissive license. No runtime fees, no splash screens, no revenue share. Just a framework that respects the person using it enough to get out of their way. The tools exist. The barrier is zero. Go make something. But what happens when you strip the tools down even further? Not zero cost, but 0 kilobytes to spare. 40 kilobytes. That's the entire memory footprint of the last Ninja on the Commodore. 64, an isometric action-adventure, with combat, puzzles, multiple environments, a soundtrack that still holds up. All living inside less RAM than a single favicon on a modern web page. Let's pull this thread, because the engineering here is genuinely beautiful. The Commodore 64 gave you 64 kilobytes total, but the operating system and hardware registers claimed a chunk of that. The game had to fit its world, its logic, its audio, its sprite data into what was left. Every byte was a decision. Every cycle was a negotiation with hardware that would punish you for waste. The sprite system on the C64 could handle 8 hardware sprites. 8. The last Ninja needed dozens of on-screen elements, so the developers used raster interrupt tricks. Reprogramming sprite registers mid-frame as the electron beam swept down the screen. The machine was literally being reconfigured 60 times per second while drawing a single image. The soundtrack deserves its own conversation. Ben Daglish and Matt Gray composed music on the SID chip. 3 oscillators and a filter. 3 voices. A modern podcast intro uses more channels than that. Yet, the Wastelands theme is genuinely moving. constraint-bred invention. Now, here's the part that matters. One commenter points out that a production service they maintain uses gigabytes of memory, but the actual data fits in megabytes. The ratio of overhead to substance in modern software is staggering. And it's not because problems got harder. It's because resources got cheap enough to stop caring. The last Ninja developers couldn't afford abstraction layers. They couldn't afford garbage collectors or runtime interpreters or dependency trees. They wrote to the metal because the metal was all there was. This isn't nostalgia. This is a reminder that the most creative engineering happens at the edges of constraint, where you can't throw hardware at the problem and you have to actually think. 40 kilobytes, a complete world, built by people who understood every transistor they were talking to. Moving on. 2.5 seconds. That's the total round-trip latency from speaking a question to hearing an answer back. Speech recognition, vision processing, reasoning, and text-to-speech synthesis. All running locally on a MacBook Pro. No cloud, no API calls, no subscription. Fikri Karim built Parler because he had a problem worth solving. He runs a free English language learning service with hundreds of monthly active users, and server costs scale with every conversation. 6 months ago, real-time voice I required an RTX 5090. Now, Google's Gemma 4E2B model fits in 3 gigabytes of RAM and decodes at 83 tokens per second on Apple Silicon. The architecture is worth appreciating. A browser captures microphone audio and camera frames, ships them over WebSocket to a local fast API server. Gemma handles the multimodal understanding. It sees what your camera sees and hears what you say. Coherent, an open-source TTS engine, speaks the response back. LÖVE in the browser detects when you start talking, so there's no push-to-talk button. You can even interrupt mid-sentence. The audio starts streaming before the full response finishes generating. This echoes something from 1993, when Simon Voices shipped one of the first consumer speech recognition systems on a 386. The hardware was barely adequate. The accuracy was rough, but it proved the interaction model was right, and everything after was optimization. Parler is at that same inflection point for multimodal AI. The interaction model works, and the hardware will only get faster. What makes this genuine bootstrapism? Every component is open. Gemma is open, weights. Coherent is open source. Celeron is open source. Parler itself is Apache 2.0. A language learner in Jakarta or Lagos can clone this repo and have a private, free, unlimited conversation tutor running on their own machine. Point the camera at objects. Talk about them in any language. Switch to your native tongue when you get stuck. The tools exist. The models fit. The future of AI isn't waiting for permission from a cloud provider. This has been your daily tech feed for Hacker News for April 6, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voice by Qting 3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that fits in your hands and punches above its weight. We'll see you back here tomorrow.